Alright, so we're going to finish up by looking at section 8.4. The last two operations we're going to do with the trig form of complex numbers is raising to powers and taking roots. So if you wanted to raise a number to a power the way we have now, like this, 2 plus 3i squared, right? You can do it. You just write 2 plus 3i, 2 plus 3i, FOIL it all out. You're going to get 4 plus 12i plus 9i squared, which is really 4 plus 12i minus 9. And 4 minus 9 gives me negative 5. So I mean, it didn't take me that long. I mean, maybe 15 seconds to do that out. Now, what would become kind of annoying is if you had to do 2 plus 3i to the 12th power. Now I have to write 2 plus 3i 12 times and FOIL everything. So that would take a lot longer. I mean, you can still do it, but it may take 10 or 12 minutes to make sure you do it carefully. Now, if the exponent started to get into the hundreds, now that's really hard to do by hand. If you're going to FOIL it out by writing 125 sets of parentheses, first of all, it's going to take you like 10 minutes just to write that. And then to do it all out, there's going to be hundreds and hundreds of steps. So chances of making a mistake somewhere, which messes up everything, pretty high. If we can write this in trig form, you can do this problem just as fast as you can do that problem. Doesn't make any difference. So that's the advantage. That's a huge advantage of trig form in this case. So we're going to look at kind of a pattern, not really a proof, just see if we notice a certain pattern and then generalize it to raise something to any power that we want. Okay, so let's take this number, just a made-up complex number. I'm not putting in a specific r or a specific theta. And let's do z squared, right? So we're going to do this kind of the long way, but then hopefully when we're done, you're going to see a pattern. So z squared really just means writing that twice. So I'll write it twice, which is kind of a lot to write, but times r. Okay, so we're multiplying four things together. R times cosine theta plus I sine theta times r cosine theta plus I sine theta. 1, 2, 3, 4. All right, so when you're multiplying, it doesn't matter the order you multiply them in. Okay, if you think of that as like A, B, C, D, multiplying four things together, you could do B, D, C, A. Doesn't matter. You just have to multiply all four together. So let's start with the first and the third terms. If you multiply the first term and the third term, what do you get? Yeah, r squared. That's the easy one. Now the rest of it has to be FOILed, right? Cosine theta plus I sine theta, cosine theta plus I sine theta. So I'm just going to pretend like that r is in front right here, and now I'm just going to FOIL this. Okay. Cosine times cosine would give me cosine squared. Then I have cosine times I sine and another cosine times I sine. So how many cosine I sines do I have? 2. 2 of the cosine I sine. 2. And I'm trying to think the order I want to write this in. It's a 2, an I, a cosine, and a sine. I'm just going to try it like this for now. You might change that, but it's basically that's what you have. And now the last term, I sine times I sine. Well, I times I is how much? Yep, which is negative 1. So we have negative sine times sine, which is sine squared. Okay, let's simplify. Let me rearrange this a little bit. I'm not going to do any simplifying. I'm just going to move different things next to each other. Let's write this as cosine squared, and let's put the minus sine squared right after it. So cosine squared minus sine squared. And then this part, I'm going to put plus, I'm going to put the I first, and then the 2, then the cosine, then the theta. Again, it's not really important, but it's going to maybe help you to see something. 2 cosine sine. Now, there's not really much you can do with r squared. But this is something. Cosine squared minus sine squared. It's not cosine squared plus sine squared. That would be 1. There was an identity for cosine squared minus sine squared. And it's from section 7.5. Does anyone remember what that one is? Yep.
It's the double angle.
Yep, it's a double angle. And what does that simplify to?
Cosine 2 theta.
Yes. That turns into cosine 2 theta plus I. Now this is another one. 2 cosine theta sine theta. That's another identity. What's 2 cosine theta sine theta? Yep.
Another double angle.
Yep.
Sine 2 theta.
That's sine 2 theta. Another double angle. That is what you get when you take the original number you had right here and square it. So when you take and square it, you get r squared cosine 2 theta, I sine 2 theta. Kind of not, we didn't prove anything, but just generalizing that. Does anyone have a guess what you would get if you were to cube it? Yeah?
R cubed cosine 3 theta plus I sine 3 theta.
Yeah. That's what you would get if you cubed it. If you did it to the 5th power, you get r to the 5th cosine 5 theta plus I sine 5 theta. You can pick any exponent you want. So the pattern is you raise the radius to the power and you multiply the angle by the power. And that is called DeMoivre's theorem. So if you want to take any complex number in trig form, it's got to be in trig form, and raise it to an integer, 6, 7, 8. This doesn't really work like if you had decimals. I'd have to double check if it works for decimals. I'm not 100% sure off the top of my head. But we're only going to use it for integers anyway. Take the radius, raise it to the power. Take the angle, multiply it by the power. And that's it. So it gives you a very, very easy way to raise a complex number to a power without having to FOIL maybe 100 sets of parentheses. So what I might do is give you one like this on the test that would be totally unreasonable to try to do FOILing out the old way. It would just be like hundreds of multiplications. This way, you can do the problem in under 20 seconds. No matter what it is, pretty much. Questions on DeMoivre's theorem? All right, so let's try an example. I want to cube that number. Now, and then I'm going to raise that to the 8. Now, cubing it's not that bad. You probably could cube something by FOILing 3 sets of parentheses out. But we'll practice using DeMoivre's theorem. Certainly, once you get to with the 8th power, I would not want to FOIL 8 sets of parentheses. That's going to take a while. So, to use DeMoivre's theorem, is this problem, is it ready? Is it ready to use DeMoivre's theorem? Yep.
No, because you have to find R and theta.
Right, I have to find r and theta. So r, we use the Pythagorean theorem. 1 squared plus the square root of 3 squared. So what is r going to come out to? R squared will be 4, but r would be 2. So radius is 2. The angle, first thing I need to know is my quadrant. What quadrant am I in here? Yeah? 1. What's the formula to find theta in quadrant 1? We can do it in degrees. Because we're going to, yeah, we'll do this one in degrees. Yeah?
The inverse tangent of y over x.
Inverse tangent of y over x. So inverse tangent of, Robin?
Confused why it's 2. My r is 2.
Because you get 1 plus 3, which gives me r squared equals 4. And then the square root of 4 is 2. So basically the square and the square root just cancel each other out and you just end up with 1 plus 3. But that's r squared and we want r. What's y in this case? Chris?
Square root of 3.
Yep. And what's x?
1.
Yeah. So we don't even really need that. So it's just the inverse tangent of root 3. We get a nice angle of 60 degrees. Okay, so now write it in trig form, and then cubing it is going to take no time at all. All right, so we've got r cosine 60 plus I sine 60. And we're going to take all of that and cube it. What's my radius going to be when I cube that complex number? 8. And what's my angle going to be? $180. Yep. And that's it. That's how you cube it. Actually, yeah, you still need parentheses. Now that's the trig form. If they wanted it in standard form, what would you do with that? They said trig form, you're done. But what if they wanted the final answer back in standard form? Yep.
You have to do distributed copy.
Yep. Distribute the 8 times cosine 180. See what you get. 8 cosine 180 gives you negative 8 plus, we'll put the I here and just figure out what number goes in front of it. 8 sine 180. 8 sine 180. It's actually 0. So in standard form, there's the answer. Negative 8 plus 0i. I mean, you could just put negative 8. But you'd have to, if this number wasn't 0, then you'd have to put what it was, like negative 8 plus 2i or something. So trig form, very easy to change it back to standard form. It's much faster to go from trig form to standard form than from standard form to trig form. Because you got to use Pythagorean theorem to do that, usually. Okay, so any questions on that one? Okay, so let's try this one. Is that one ready to use DeMoivre's theorem? No. So let's get our radius. So we're basically squaring the same thing twice. Doesn't matter that this one's negative. When you square it, it's going to go away. So what's root 2 over 2 squared? A half. Square it in the top, you get 2. Square it in the bottom, you get 4. So you get a half. And then you get root 2 over 2 squared. It's 2 over 4 again. So that's another half. So my radius squared is 1. What's my radius? Square root of 1, which is 1. So in that case, the radius is just 1. Now we need the angle. Now, each leg in the triangle is the same length. So what kind of triangle am I going to be drawing here to find the angle? Yeah.
45, 45, 90.
Right, it's going to be an isosceles triangle, specifically a 45, 45, 90, which means this angle that I'm going to find is a multiple of 45. So if I was doing this, I wouldn't even bother with inverse tangent and all that stuff. I would just figure out what quadrant I'm in and then figure out what the 45 is in that quadrant. Left, up. I'm in quadrant 2. What's the 45-degree angle that's in quadrant 2? 135. So you could just do it that way. Or, if that doesn't work, do the inverse tangent of y over x. That's going to be the inverse tangent of -1, and you're going to get -45. But then you have to add 180, because you're in quadrant 2, and that will also give you 135. So you can use the exact same formula we've been using, but when it's a 45, 45, 90, you're limited to 4 answers. 45, 135, 225, or 315. Okay, so now let's write our number. You don't need r. R is only 1, so it's not as important. So cosine 135 plus I sine 135. I mean, if you want to put the 1 in, you can, but... And what power are we raising that to? 8th, well, yeah, 8th, okay. So raise it to the 8th. Okay, what's my radius going to be when I raise it to the 8th power? Not 8. 1. It's just 1 times 1, 8 times. So 1 to the 8th is still 1. And this is a little bigger. What's the calculation to get my angle?
8 times 135.
It's 8 times 135. So it's 1080. But what if they ask you to write the answer so the angle's between 0 and 360? What could you do to that angle to make it smaller? Yeah, they may ask you to make it smaller. So if they don't, you can just leave 1080. But if they want it smaller, it's actually the same as a 0-degree angle. 1080 is just 4 revolutions. That's all. So it's the same as 0. So think about what the coordinate would be for that. You're at an angle of 0, and you're 1 unit away from the origin. What would be the coordinate? I mean, you could just distribute it out and see, but that's an easier one to figure out. You're at an angle of 0 and 1 unit from the origin. Where is that? Yeah? Well, it's not going to be in a quadrant, right? Because you have an angle that's a quadrantal angle. Yeah?
1, 0.
That's going to be the coordinate 1, 0. Because you're at an angle of 0, which is the positive x-axis. And you're a radius of 1, which means you're 1 unit away from the origin. So all that is 1 unit right. If you distributed this out, the cosine of 0 is 1, times 1 is 1. The sine of 0 is 0, times 1 is still 0. So that's where the coordinate, you don't have to write that part, that's where the coordinate would be. Okay. But we'll just leave this one in trig form, because I think they just said find. But you can just leave it in trig form. Okay. So any questions on that one? Yeah?
How did you find theta?
Theta? So you just did 135 times 8.
Yeah, but the first part.
The first
You
part.
got 135.
Because that's an isosceles triangle, and it's left and up. So that means these two sides are congruent. So that has to be a 45-degree angle, which means that has to be 135. Because the whole, well, Yeah, if you went all the way around, that would be 180, and you're 45 degrees short of going all the way around. Or just do inverse tangent of y over x and then add 180. But there's a faster way to do this one. Now, if you change this bottom 2 right here to like a 3, then I have no idea. Then it wouldn't be an isosceles triangle. I'd have to just do the whole thing out. Okay. Any other questions on that one? All right. So let's think about what we did on the first example. Go back. We took a number and we cubed it. What's the opposite of that?
Cube rooting.
Cube rooting. So if I took that number, not that number, if I took that number and cubed it, and I basically got this. When I cubed that problem, I got -8. What does that mean if I take the cube root of -8? What would I get?
Is 2 or 2i.
Well, those are other answers, but yeah.
1 plus square root of 3i.
We go right back to what I started with. This number is the cube root of -8. There are 3 answers when you take the cube root of 8. 2. 2. 1 plus root 3i, and also its conjugate, 1 minus root 3i. We didn't quite learn that yet, but we've learned in the past, usually when you have conjugate answers, they come in pairs, and that works with roots as well. So if you know you have a complex number that's a root, so is its conjugate. All right? So you cube that, you get that. If you cube root -8, that's one of the answers you would get. 1 plus root 3i. And I think I write that down. Actually, I just said it, so I'm not going to write it down. So how would you reverse what we did? You would take a cube root. So if we took the cube root of -8, 1 out of the 3 answers is 1 plus root 3i. The higher the root you take, the more answers you have to find. So if you're looking for a 5th root, you should be looking for 5 answers. 12th root would be 12 answers. And there's a pattern to how you find them. On the test, you could probably expect to maybe finding up to, you probably have a cube root problem, maybe a 4th root problem. Probably not, you're not going to have like a 12th root problem. That would take a while. It's not harder. It's kind of like the 2 solution case with law of sines. It's longer. You got to keep doing the same thing 12 times in a row. All right. The last thing we're going to look at is how to take roots. This is all going to be based off trig form. If they don't want final answers in trig form, that's fine. You can always distribute at the end and change it to standard form. But you have to do all the work in trig form. So this is going to be the basic equation that we set up every time. We just have to translate that into trig form. Okay, and I'll show you with actual numbers how that would make sense. Let's say you were looking for the 3rd root of 8. Okay. You were looking for the 3rd root of 8, just to plug in 2 specific numbers. That would mean n is 3 and a is 8. So if you wrote that down, if you can figure out the answers to that equation, then you can figure out what the cube roots of 8 are. So that's the equation you would have to solve to find the cube roots of 8. We're not doing that one right now, maybe later, but any question on that equation? Now that's not in trig form. How do I know it's not in trig form? I don't see cosines and sines anywhere. Okay, I gotta get it into trig form. So that's going to involve a couple things. You're going to have to take the number on the other side and change it to trig form, and you're going to use DeMoivre's theorem right there because you're going to have a complex number to a power. So DeMoivre's theorem always comes in on the left side, and on the right side, this is just going to be some complex number and you're going to have to change it to trig form, just like last night in the homework. If they ever say find the roots of unity, this is like the only one that has a special name. What they're really asking you for is the roots of 1. That's all that means. So like if they said find the square roots of unity, all they're saying is find the square roots of 1. What are they? And a square root problem would be pretty easy, because there's only 2 answers to a square root problem. Right, so that's just more if you see like a vocabulary thing. If you see that phrase, it just means 1. That's all. Now, I'm going to write the steps out for how to do it. The steps are kind of lengthy. If you don't like steps and you don't want to write them, and you just want an example, you could just write the example. But what I'll do for the first one is I'll do an example after I write each step. I'll do that step in the example. So the example we're going to do is we're going to find the 4th roots of unity. In other words, I want to solve this equation. If you can solve that, something to the 4th power gives you 1. That's what I want to know. What is something that you raise to the 4th power and get 1? Now, a couple answers we could probably already figure out. This doesn't really help us because we're going to figure them out again anyway. But what can you raise to the 4th power and get 1? 1. So when we go through all the work, you're going to see 1 come up as an answer. And what else? Yeah. -1. So when we go through all the work with the sines and cosines, you're going to see that come up as an answer. 1 and -1. Those are the only 2 real numbers that are solutions. So the other numbers are probably going to be what? They're not real. They're going to be imaginary, and they're going to be conjugates. So once you find one of them, like say it's 2 plus I, the other one is 2 minus I. Right? But we're just going to find them all. All right. So basically what that says is we're trying to, when you want to find nth roots, you set up an equation like that. That's your first step. Now remember, the 2 numbers z and a in this equation can be complex. That's what that says. Z and a can be complex numbers. They don't have to be real numbers. So in this problem we do, you will get 2 answers that are real for z. You're going to get 2 answers that are complex. So the first thing we're going to do is we're going to rewrite z to the n equals a. We're going to rewrite this equation in trig form. The left-hand side always starts out pretty much the same in every problem. The right-hand side is different depending on the number that's there. So, all right. So let's just put that like that. Z is going to be exactly what I wrote there every time. That's exactly what you're going to fill in for Z. A is not. R and theta, you have to find them. Okay? You don't have to find R and theta here. Not yet. But you do have to find R and theta here based off that number. Okay? So let's start with the left-hand side because that's easy. Literally just copy what I have for Z and change it on the right-hand side. So it's R cosine theta plus I sine theta to the 4th. And that's the whole goal. You're trying to find the radius and the angle for the answer to this problem. Okay. Now we have to do the right-hand side.
How many more lines of steps is there so I can work?
I think there's probably like maybe 4 lines. 4 or 5. It depends how big you write, but yeah, I have about 4 more steps. Some steps may take up a little bit more room than 1 line. I'm not sure. All right, so we've got that. And now, on the other side, what we're going to do is we're going to rewrite 1 in trig form. Okay, so let's graph it. What's the real part in the number 1? 1. What's the imaginary part? 0. So when you graph it, there's your point. To write that in trig form, you need two things. You need the radius and you need the angle. Now this one's an easy one because it's on the axis, but let's go through it just like we didn't know. You use Pythagorean theorem to get the radius. So I'm just going to kind of do this up here. You don't really, I mean, we already know what the radius is because it's right on the axis. You would do 1 squared plus 0 squared equals r squared. Square the real part, square the imaginary part, add them up and take the square root. So that's 1 equals r squared. So r is just 1. So that's what you put here. Now you need the angle. Now again, since it's right on the axis, you probably already know the angle. And we can just go with that. So we're on the positive x-axis. What's the angle? 0. If I wasn't on the axis, I would have just done inverse tangent y over x. So this side is different in every problem. You have to look at your number and change it to trig form. This side, this part is always exactly the same. The only thing that's different on this side is the power. Maybe it's a 4, maybe it's a 5, something like that. So now at this point, you have something like this. And I wrote it like this. So there's your left-hand side, but we have a specific power filled in for n, and there's your right-hand side. But we have a specific radius that we calculated, and a specific theta that we also figured out. Now, in the next step, the right-hand side is going to stay exactly the same. But the left-hand side, we can use DeMoivre's theorem on and do that out. So what's my radius going to be on the left-hand side? Yep. Yep, it's going to be r to the 4th. And what's my angle going to be? 4 theta. Yep. So 4 theta plus I sine 4 theta. Right side stays exactly the same. You don't even really need the 1 there, but I'm going to keep the 1 there just so you can see what it looks like when you keep it. Sine 0 plus I sine 0. Sometimes what I do is I just jump right to the second step. R to the 4th and 4 theta. I don't even write that first step, but you can. Right, so now, if you want to kind of look at what you have generically, you're always going to have something like this. R to a power, in our case it's 4, and you're going to have the power times your angle. In our case it's 4 again, power times your angle. Okay, and now we're ready to set up the two equations to find the r and to find the theta. You have basically, well, let me show you. You've got a radius on the left and a radius on the right. Those have to equal each other. Whatever the number is in front of the parentheses on the left, that has to somehow equal the number in front of the parentheses on the right. Why? Because there's an equal sign between the left and the right. So those two things have to come out the same. And now we're going to solve that. And the other thing that has to come out the same is that angle has to match that angle. Those two angles have to match. If you can make them match, find something you could plug in for theta to make it match, then what's on the left and what's on the right would be the same. So the two radii have to match and the two angles have to match. So let's write that down. 4 theta has to equal 0. And now there's something I can add onto the end of 0. Because when you find an angle, what can you add or subtract to an angle and it's still the same angle? Yep.
2 pi or 360.
2 pi or 360. So we've got that on the left. R to the fourth equals 1. And then on, let's see, on the right, we don't have an n, we have a 4. Right? We have 4 theta equals the angle, which we had 0, or anything that's coterminal with it. Okay? So you can add or subtract 360, and that's what gives you the other answers. If you didn't add the 360 or the 2 pi, you would only get one solution. Adding the 2 pi k is what gives you all of them. You know what? I kind of did this one in degrees, so I'll just put 360 above it, and we'll do this one in degrees. So it's a little bit to get used to, but once you do a couple, it's not as bad. First one's a little rough. So when you're finding, I already said this, when you're finding roots in trig form, you only get one answer for r. R is always the same, but you get many values for theta. How many answers? Depends on the root. You always get as many answers as the index of your root. So we're going to get 4 answers here. How do you get the 4 answers for the angle? Well, you substitute in a number for k. You start at 0. If you want to get 4 answers for k, you're going to plug in 0, 1, 2, 3. That's how you get the 4 answers for k. So you plug in starting at 0 up to 1 less than your root you're finding. If you went to 4, that would be too high. 0, 1, 2, 3, 4. That's 5 answers. You don't want 5 answers. You want 4 answers. Okay. So in this case, k equals 1 through 4. And now that's all we have to do. Now use that information to write our final answers. Okay, let's start by finding the radius. Just take the 4th root of each side. You can use your calculator, and I'll just show you in case you get a number you can't do in your head. Take the 4th root of each side. So I want to know the 4th root for math option 5. The 4th root of 1, which is how much? 1. So my radius is 1. Now I'm going to write all 4 of my answers. K equals 1, 2, 3, and 4. I'm going to set them all up with r as 1 right now. Yep.
Did you say to start at 0?
Oh, 0. Yeah, thank you. Yeah, do what I said, not what I wrote. So now I'm going to set them all up. Even though I don't need the 1, I'm going to write it, because sometimes it might not be 1. 1 cosine angle, I sine angle. You're going to write that 4 times. 1 cosine angle, I sine angle. 1 cosine angle, I sine angle. This is where it starts to get kind of tedious now. 1 cosine angle, I sine angle. Okay. So now let's look at our formula. We've got 4 theta equals 0 plus 360k. I want theta, not 4 theta. So how would I get theta by itself on the left? Divide by 4. So 0 you don't even need, right? When you add 0 to something, that one doesn't make a difference. What's 360 divided by 4? Yeah, 90. So there are all your angles. Your angles are multiples of 90. And basically what happens, I don't really want to get into it too much, but your answers are all 90 degrees apart, which means your answers are going to look something like this. All these answers are nicely spaced. You wouldn't get like 4 answers all clumped together. If you draw out every answer we're going to get, they're all nicely spaced. If you did a cube root problem, they would be the vertices of an equilateral triangle. They're all nicely spaced. If you did a 5th root problem, they would be the vertices of a pentagon. Nicely spaced. Right, so all the answers are very nicely spaced. You don't have to know that, I'm just showing you. Okay. Here's our formula for theta. Let's start with 0. What's 90 times 0? 0. There's your first answer. K equals 1. What's 90 times 1? 90. There's your second answer. K equals 2. What's 90 times 2? 180. Here's your third answer. And K equals 3. What's 90 times 3? 270. 270. 270. There are the 4 answers to the problem in trig form. Now, when we started, we said, well, shouldn't 1 and -1 be an answer? Yeah, that's up there. If you do those out, one of them will come out to 1. Let's see. Do out the first one. Cosine of 0 and distribute the 1 to it. You get 1. Do out the second part. 1 times the sine of 0. 1 sine 0. The second part is 0. So this is really just the number 1. And that's one of the answers we said we would get. Now, we also said we would get 2 imaginaries. Well, let's do the second one. 1 cosine 90. 1 cosine 90. That's 0. First part's gone. Do 1 sine 90. 1 sine 90. You get 1. 1 times I. That answer is just I. Okay. If you did this one out, distribute. You don't even have to distribute the 1 because it's just a 1. Cosine 180 gives you -1. Just trust me that sine of 180 gives you 0. So this one, there's your -1. And the last one, this part, cosine 270 is 0. That's gone. The sine of 270 is -1. -1 times I is -I. So those are the 4 answers if they asked you to change them to trig form, standard form. 1, -1, I, -I. Okay, we're going to try another one of those. And as I said, if you were to graph them, that's 1 unit right, 1 unit up, 1 unit left, 1 unit down. They're the vertices of a square. Okay, but just remember, you got to find as many answers as the root you're looking for. All right. Let's do this one because it's kind of it's a little bit easier, and then we'll go back to one like that. They want me to prove that that is one of the 8th roots of 1. So there's 8 answers. They're not asking for what the 8 answers are. They're just saying, prove that this is one of the 8 answers. So if I said to you, prove that 2 is the cube root of 8, how would you prove that? How would you prove to somebody that 2 is the cube root of 8? Cube 2. Say, look what you get. If you take 2 and you cube it, you get 8. So, how do you think we can prove this is the 8th root of 1? What could we do with that? Yeah. Put it to the 8th power and hope that we get 1. So raise this to the 8th power, and if you get 1, that's just like taking 2 and cubing it. You just prove to somebody that's the cube root of 8. So let's raise that to the 8th power and see what we get. It's already in trig form, so we don't have to find the radius or the angle. What is the radius there? It's 1. So when I raise it to the 8th power, the angle is still 1. So let's just call this complex number z. So I don't have to write the whole thing again. So z to the 8th power. Radius is still 1. What's going to be my angle when I do what I need to do with DeMoivre's theorem? Yep. 2 pi. You multiply the angle by the power. Well, the power is 8. The angle is divided by 8. So that makes it kind of nice. It just turns into 2 pi. So that's the answer in trig form when you raise that to the 8th power. Let's do it out and see what it comes out to. Just so I don't have to switch the mode. 2 pi is what in degrees? 360. So we get 1 plus I times 360. 0. I times 0, gone. When you raise that number to the 8th power, you get 1, which means it must be the 8th root of 1. There are 7 other answers too, all distributed around an octagon. So knowing that they're distributed on an octagon, you can figure out just from geometry how far apart each answer is. And that's how many degrees you would add each time to get the second, the third, the fourth, the fifth answers. You don't have to find them here, but there are shortcuts to what I'm showing you, but we'll just stick with using the same method over and over, and hopefully eventually it'll kind of sink in. So any questions on this one? How we prove that's the 8th root of 1? All right. I don't really want to graph the cube roots of -1. Let's do something. All right, we'll do another one kind of like what we did before. Let's do this one. Let's find the cube roots of -8. How many answers should I be looking for? Chris?
3.
Yep, looking for 3. So let's set up our equation. Just go back so you can see it again. Set this up. Z to a power equals A. Remember, n is the root you're finding, cube root, 4th root. A is what you're finding the cube root or 4th root or whatever of. So in this one, it's going to be z to what power equals what number? Yeah.
Z to the 3rd power equals 7.
Yep. Now, turn that equation into trig form. Does anybody remember what I put on the left-hand side for z? This never changes. Yeah.
You put r times cosine theta plus I sine theta all to the 3rd one.
Yep. We're going to do all of that. And technically I should do it like that. You're doing all of that to the 3rd power. And now on the right side, you want to take -8 and turn it into trig form. Where's negative? Well, what's the real part with -8? Yeah. -8. What's the imaginary part? 0. They're not all going to be 0, but this one still is. So you're left 8, you don't go up and down at all. What's my radius for that problem? You don't really need Pythagorean theorem because you're on an axis. So you can just count how much you moved. Rob? Do you know what it is?
-8.
Careful, radius is always what kind of number?
8, yeah.
Yeah, radius is always positive. And what angle are we at on that coordinate plane? 180. So your angle is 8 cosine 180, I sine 180. Now, on the left-hand side, we have something we need to do out. I got to use DeMoivre's theorem. What would the left-hand side become if we do that? Okay. Do you see what the left-hand side would be, what it would turn into if we used DeMoivre's theorem?
Yeah, we R cubed.
Yep.
Cosine 3 theta.
Yep.
Plus I sine 3 theta.
Perfect. I'm just going to put equals like that so I don't have to write the right-hand side again. Now you're ready to set up your equations to solve. Can anyone tell me what the equation for the radius would be? Yeah. R cubed equals 8. Let's just finish that off right there. What's the cube root of 8? 2. So every answer that you write is going to have a radius of 2. Now, there's my radius. What's the equation I set up for my angle? Yep.
3 theta equals 180 plus 360.
Perfect. The angle on the left equals the angle on the right, or anything that is coterminal with it, adding the 360k. Now we can simplify and get theta by itself by dividing everything by what? Yep, and you got to do everything. 3, 3, 3. And there is your formula for theta. So now using what you know the radius is and your formula for theta, we can write our answers. What are going to be the values we plug in for k?
0, 1, 2.
0, 1, 2. That's how you get the 3 answers. 0, 1, 2. Radius is 2. In all of them. And then just write this 3 times. Okay, k equals 0. 120 times 0 is how much? Plus 60. There's your first angle. Remember, these are going to be the vertices of an equilateral triangle. So if you think of 360 divided into 3, so you're moving 1/3 of the way around each time, that's why you're adding 120. That makes it the 3 points to get all the way around. Next one, k equals 1. 120 times 1 plus 60. 180. 80. 80. And k equals 2. 120 times 2 plus 60. 300. And those are the 3 answers. Now, one of those you probably knew already. What's one number you can multiply by itself 3 times and get -8? -2. That is that answer right there. If you do 2 cosine 180, watch what you get. 2 cosine 180. -2. You say, well, what about the other part? Well, it doesn't matter. 2 sine 180 What do you think that's going to come out to?
0.
Yep. The other part is just 0. So that is the -2 that you just told me. So what do you think that means about the other two answers if I were to do them out? Yeah?
Imaginary.
Imaginary. And once I do the top one, I automatically know the bottom one. If the top one was like 1/2 plus 3i, the bottom one would be 1/2 minus 3i. They would be conjugates. I'm not going to do them all out. But those are your three answers. Any questions on that one? Alright. Let's do the fifth roots of 1 plus I. So I'll do one more. Let's start with the left-hand side. Now, can anyone tell me what the left-hand side is going to be? And let's do DeMoivre's theorem to it at the same time, so we don't have to write it twice. Yep.
R to the 5th times cosine 5 theta plus I sine 5 theta.
Yeah. So I like to get that step out right away. R to the 5th cosine 5 theta plus I sine 5 theta. Now, you have to write that number in trig form. That's what we did in the homework last night. Right one, up one. What would be my radius if I go right one, up one? This is where you'd have to use Pythagorean theorem. No, it wouldn't be 1. Because if all the sides were 1, then it would be an equilateral triangle. But this is a 90 right there. Nate?
Is it 0.8125?
Well, it's the hypotenuse, so it's got to be the longest side. So the legs are each 1, so it's got to be bigger than 1. It's a decimal. Actually, I do know what the decimal is, but
Oh, it's a decimal.
yeah, we're going to leave it, though, as an exact answer.
Oh, so square root of 2.
Yeah, it's the square root of 2. It's about 1.4. Okay, but let's just write it as square root of 2. And now, you could do inverse tangent of y over x. So it's the inverse tangent of 1 over 1, but that's an isosceles triangle. So what would the angle have to be there?
45.
It would be a 45. Yep. Okay. Now we're ready to set up our two equations. Let's start with the one for the angle. Someone give me the equation for the angle. Yep.
5 pi equals 45 plus
5 theta equals
45.
Yeah.
Plus 360k.
Okay. And now what do I do to get theta by itself? Divide by 5. Yep. Um, 45 divided by 5 gives me 9. 360 divided by 5 is 72. Yep. And if you know anything about pentagons, if you're going around a circle, each vertex would be 72 degrees apart to get all the way around. With a K. Okay. So we'll come back to that. Well, we should write, what is K going to equal to get 5 answers?
0, 1, 2, 3, 4.
So 0, 1, 2, 3, 4. Yeah, we just get 5 answers. You're right. 0 to 4. Okay, my radius. What's my equation for my radius? Yeah.
R to the 5th equals root 2.
R to the 5th equals root 2. Now, I don't like mixing equations that have exponents and radicals in the same equation. Pick one or the other. Let's do it like this. What exponent means the same thing as a square root? Yep. To the 1/2. Okay. Now, my goal is to get r by itself. What power could you raise each side to do that? Because remember, when you have a power to a power, you multiply. So I'm trying to think, 5 times what gives me 1?
Negative 5? No.
No, that would give me r to the negative 25th. 1/5. If you raise each side to the 1/5, power to a power, you multiply. 5 times 1/5 cancels. And what's 2 to the half to the 5th? 2 to the 1/10. If you don't want to write it as 1/10, that's the same as writing the 10th root of 2. Either way. It's the same. Doesn't matter. Okay, so in all 5 answers, that's going to be my radius. Alright, so k equals 0, 1, 2, 3, 4. So hopefully you're feeling a little bit better than the first problem, kind of seeing it, at least it's repetitive. It's the same thing every time. It's just kind of a lot to write. So now we got to do the 10th root, and what I'm going to do is I'm going to do it like this. You can't do this, but cosine plus I sine, and I'm just going to copy that. Or if your notebook has a clone button, just press that. Anyone have that? No? Yeah, you? Okay. I don't even know if this is that much faster. Okay, so now fill in all our angles. Start with 0. 72 times 0 plus 9. 9 degrees. Now, all you're really doing each time is adding another multiple of 72. You're going to do 72 times 1 plus 9, 72 times 2. So just add 72 each time. What's 9 plus 72? 81. Okay, and just so we don't make a stupid mistake, let's just use the calculator. Plus 72, 153. Now you're going to do the 72 times 3 plus 9, which is 225. And the last one is the 72 times 4 plus 9, so add another multiple of 72, and you get 297. Now, if you accidentally added 72 again, which you shouldn't, you would get this, 369. What can you subtract from that to make it smaller?
360.
You can subtract 360. You already did 9. That was the very first one. So if you go too far, you're just going to repeat ones you've already done. Okay, so that's the method for finding roots. Again, I wouldn't expect anything on the test higher than like a 4th or 5th root. You're not going to have like a 10th or 11th root or anything like that. Maybe up to 4 or 5. Okay, and I'm pretty sure there is a cube root as well. Alright, so the homework, it's 2 through 5, 7 through 12, 17, 25 to 28, 34, and 35. Okay, so we'll look at that tomorrow. I'll be after school for extra help if you need it. If you took a test, progress reports I think are being printed now for being distributed tomorrow. So I didn't get your progress report updated with your test if you just turned it in this morning. But it'll be on your turn.